welcome back to the chapter sets. Now we are in second part of this chapter. In the first part, we were discussing about the definition and the characteristics types of sets, and we discussed up to improper subsets. Okay, then now we are discussing about finite sets, infinite sets, and the power sets. Finite sets are sets nothing but it is finite, isn't it? And the finite കുറച്ച് it can be counted, isn't it? It is clearly visible in front of us. See, P is equal to set of divisions of 10th standard in your high school. You just remember your high school periods and your 10th class or 10th division or 10th standard is subdivided into further divisions. 10th A, 10th B, 10th C. Okay. Suppose these are the divisions of your 10th standard. 10th A, 10th B, 10th C, 10th D, E, F, G, H. Clear? Anyway, some of the schools have 10th standards up to Z. Okay, up to Z. Anyway, they are limited or finite. We can count this or we can understand this, isn't it? So such sets are called as what? Finite set. So see this example. Set of natural numbers from 1, which are natural numbers, what? 1, 2, 3, 4, etc. Set of all natural numbers starting from 1. That is, it is non-stopping or non-terminating, isn't it? ഇത് നിൽക്കൂല, സ്റ്റോപ്പില്ല. 1, 2, 3, 4, 5, 6, etc., etc., etc. And this set or this set Q is approaching to what? Infinity. Commonly, set of natural numbers is represented as what? Capital N, natural number. So this set elements are approaching to the infinity. What is infinity? It is an imaginary number, a big number, 1, 2, 3, 4, 5, 6, etc., 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 up to infinity. So this is infinite, isn't it? Its end part cannot be seen. So these are difference between finite and infinite set. You are again asked to write the set of all stars, or you are asked to count all stars in this Milky Way. So there will be several stars which is uncountable. We can't predict the numbers, isn't it? So such sets are examples for what? Infinite sets. These are examples for finite and infinite sets. Let us discuss what is power set. Power set, it is denoted as capital P. As we discussed in the last class, we are taking capital A is equal to set 1, 2, 3, 4. It is a set. A number of elements in the set is what? 4. 1, 2, 3, 4. There are 4 numbers. So A is equal to set 1, 2, 3, 4. Okay. Clearly, A is the improper subset of this A. Isn't it? So it is named as, suppose A1. A1. It is named as capital A1. A1 is the improper subset of this A. What is improper subset? Improper subset is a subset, but it is identical set or equal sets to. Same. So improper subset. Okay. Then another subset. 1, 2, 3. It is another subset. So I am listing out all the subsets of this A. But what is A3? 1 or 2, 3, 4. It is another subset. A4 is equal to set 1, 3, 4. A5 set 1, 2, 4. Okay, these are subsets of the set. And what is F6? Set 1, 2. A7 set 2, 3, A8 set 3, 4, A9 set 1, 3, A10 set 1, 4, A11 set 2, 4, A12 is equal to set 1. It is also a subset. A13 is equal to set 2. A14 is equal to set 3. A15 is equal to set 4. A16 is equal to, this is also a subset for every set. Null set is also a subset for every set. Null set are the same set. This is improper subset. This is also a subset. So you can take null set for as a subset for every question or every set. So these are the subsets of this set. So this list is complete. All the subsets were listed out here. So I have got 16 subsets for this set. Okay, here number of A is equal to 4, and now I got 16 subsets, which are the A1, comma, A2, comma, A3, A4, A5, A6, etc. up to A16. So I am taking these subsets as a single set and it is labeled as capital P. Then this P is called as power set. So what is power set? Power set is a big set which consists of all subsets of a given set. If you are given a set capital A, then you list out all its subsets including improper subset and null set, empty set. Then list out or arrange all these subsets in roster form. Then this big subset or then this big set is called as what? Power set. So power set has different properties, and now I got 16 subsets. Then we can change the number of elements. Then we can observe the pattern of the number of elements in a power set. Okay, so here A is equal to 1, 2, 3, 4. Number of elements in power set is equal to 16. Okay, so this is a power set. It is a power set with 16 elements. So what is to be remembered here for identifying or for writing power sets? You list out all the subsets of a given set by including improper subset and null set. Let us take another set. Second question. A is equal to set 1, 2, 3. What is n or B is equal to? What is n of B? Number of elements in the set n of B is equal to 3. Then what will be n of P? What will be n of number of elements in the power set? So let us take. Here A is equal to 1, 2, 3. Firstly, we are taking A1 or B1, B1, not A1, B1. B1 is equal to set 1, 2, 3. Same set. It is improper subset for this set capital B. Then what's B2? Order is not important. You can take any subset as in second step. Okay, 1, 2, 3. Then 1, comma 2 is another one. B3, 2, 3. Okay. So you can take 2, 3 here, 1, 2 here also. No problem. B4 is equal to set 1, 3. B5 is equal to set 1, B6 is equal to set 2, B7 is equal to set 3, B8 is equal to null set. Null set. So this is a complete list of all subsets. You can't find any other subset as B8, B9. There is no other subset to write to continue after B8. So I am listing out all the subsets here. So there are what 8 subsets here, in which one is empty set and another one is an improper subset. So here 8. So if a set consists of 4 elements, the number of elements in its power set will be 60. If it is 8, then number of elements in its power set will be 8. If it is 3, then its number of elements in its power set will be 8. So you understand the pattern of answer. That is pattern of number of elements of the corresponding subset. If it is 4, answer is 16. If it is 3, answer is 18. 8. Then we can take another one as third category. Suppose C is equal to set 1, 2. Then can you imagine the number of elements in the power set? Yes, let us check. C1. What is C1? Same set 1, 2. C2 set 1. C3 set 2. C4 null set. N of C is equal to 2. N of power set is equal to 4. So what is a trick or formula used here? Used here, used here. Here 16, here 8, here 4. We know that 4 means 2 square, 4. Okay. 8 means what? 2 cube. 2 into 2 into 2, 8. And what will be this one? 2 raised to 4. 2 into 2 into 2 into 2. 2 into 2, 4. Into 2, 8. Into 2, 16. Okay. So this is a trick used here to find out the number of elements in the power set of a set. So generally, what is to be noted here? Note, if a set with elements with 4 elements, if a set with 4 elements is taken, then the number of elements in its power set will be 16, isn't it? If you took a set with 4 elements, if there is a set with 4 elements, or if a set with 4 elements is taken, then the number of elements in its power set will be 16, or 16 means what? 2 raised to 4, 2 raised to 4, 2 raised to this 4. If we considered a set with 3 elements, the number of elements in its power set will be 2 raised to 3, that is 8. And if a set consists of 2 elements, the number of elements in its power set will be 2 raised to 2, that is 4. And if we took a set D as or element only as 1, that is singleton set, then what will be D1? D1 is equal to same set improper. Then D2 is equal to what? Null set. That is n of D is equal to 1, then n of P is equal to 2. So like this here what? 2. There is 2 raised to 1. 1, 2, 3, 4. If a set with one element, then the number of elements in its power set will be what? 2 raised to 1. 2 raised to 1 means 2 itself. 2. Generally, if a set with n elements, then the number of elements in its power set will be what? 2 raised to n. So this is a result obtained here. This is to be learned by heart. So criteria or concept or property behind number of elements in the power set. So think from where we got this 2. നമുക്ക് എങ്ങനെയാണ് ഈ 2 കിട്ടുന്നത്? അത് നിങ്ങൾ ആലോചിച്ച് നോക്കുക. എങ്ങനെയാണ് എവിടെ നിന്നാണ് ഈ 2 വരുന്നത്? ഇതൊക്കെ 1, 2, 3, 4. From where we got 4, that is number of elements in the given set. And this 3, yes, okay, number of elements in the given set. Is 2, okay, number of element in the given set. But എല്ലാത്തിലും this 2 is common, okay. അപ്പോൾ അത് എങ്ങനെയാണ് കിട്ടുന്നതെന്ന് നിങ്ങളൊന്ന് മനസ്സിലാക്കി നോക്കുക. അപ്പോൾ ഇതാണ് power set. So power set is a set which consists of all subsets of a given set. Next, subset of set of real numbers. Then what are real numbers? Real number മുമ്പ് ഞാൻ പറഞ്ഞിട്ടുണ്ട്, നമ്മൾ 10th വരെ പഠിച്ച എല്ലാ നമ്പറുകളും റിയൽ നമ്പേഴ്സ് ആണ്. അപ്പോൾ ഇനി നമ്മൾ റിയൽ നമ്പർ അല്ലാത്ത മറ്റേ നമ്പർ ഈ 11th ക്ലാസ്സിൽ 11th പഠിക്കും. So the numbers which you had learned up to 10th standard are what? Real numbers. So all real numbers can be taken in a straight line, which is called as what? Number line, real number line. Real number എന്ന് പറയുമ്പോൾ 1, 2, 3, 4, these all are real numbers, because all natural numbers are real numbers. 1, 2, 3, 4, these are real numbers. 0, 0, 1, 2, 3, 4, these all are real numbers. 0, 1, 2, 3 means whole number എന്ന് പറയാം, WHO whole number. They are also real numbers. That you have learned up to 10th standard. 1.1, 1.2, 1.3, these all are real numbers. 1/2, 1/3, 1/4, all are real numbers. Root of 2, root of 3, root of 4, all are real numbers. -1, -2, -3, -4, they all are real numbers. So set of real numbers means a number line. Real number line, R, real number line. So this line consists of every number which you had learned up to 10th standard or up to this moment. Okay, its middle value is 0, 0, middle value. Okay, right side of this is taken as positive and the left is taken as negative. Okay, then 1, 2, 3, 4, 5 and so on. It moves up to infinity and so far. Okay, -1, -2, -3, -4, -5 അങ്ങനെ ഇത് -infinity പോകും. -infinity means it is an infinity point which is unknown. Similarly, plus infinity is a point which is still unknown. നമുക്കറിയില്ല, അങ്ങനെ പോകും. Real number means here 1, then 1.1, 1.2, 1.2, there will be lots of numbers. We can't count it, or we can imagine the numbers between 1 and 2. Okay, here 2 and 3, here 2.5, isn't it? 2.1, 2.2, 2.3. So the numbers, real numbers between 2 and 3 is uncountable. Infinite set. So between each portion there will be lots of numbers. നമുക്ക് പറയാൻ പറ്റില്ല. Then can you take a subset from this number, like real number set? See, I am taking a subset from here to here, 1 to 4, including 1 to 4. Subset of real number set are from 1 to 4 is equal to, So 1 to 4 means 1.0000001, 1.00002, etc., 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 up to 3.9999999, then 4. So there will be uncountable numbers. നമുക്കത് ഇമാജിൻ ചെയ്യാൻ പോലും പറ്റില്ല, അത്ര ഒരുപാട് big numbers, large numbers, uncountable number, infinite set. So this can be represented by this notation 1, 4. Isn't it? 1, 4. So a number, a subset of R from 1 to 4. 1 to 4 means this portion including 1 and 4. Including 1 and 4. Including 1 and 4. Okay. Is taken as this symbol. After this symbol there is 1, 4. This is said as closed interval 1, 4. Closed interval, closed interval 1, 4. Closed interval 1, 4. What do you mean by closed interval 1, 4? Closed interval 1, 4 is a subset. Closed interval 1, 4 is a subset of R, which is proper subset. It is a small part, proper subset of R. So subset of set of real numbers can be taken as interval sets. Interval sets. Closed interval. Similarly, open interval. Open interval means this one, 1, 4. So bracket is changed, 1, 4. It is not as open interval 1, 4. It is also a part of R or subset of R. But here 1 and 4 are excluded, not included. 1 ഉം 4 ഉണ്ടാവില്ല. ഈ 1 ഉണ്ടാവില്ല, 4 ഉണ്ടാവില്ല. Here 1 and 4 are excluded. 1 ഉണ്ടാവില്ല, 4 ഉണ്ടാവില്ല. So 1 not belongs to this open interval 1, 4. Similarly, 4 not belongs to 1, 4. This is to be remembered. Here 1 belongs to closed interval 1, 4. 4 belongs to closed interval 1, 4. This is the difference between closed and open intervals. Okay, so closed interval is denoted by this notation 1, 4. It is a part of R or subset of R. Similarly, open interval is also a part of R, part or subset of R. What is the difference between closed and open? Closed interval means closed interval 1, 4 means all the real numbers between 1 and 4 including 1 and 4. Between 1 and 4 including 1 and 4. Generally, closed interval a comma b is equal to what? There are enough and more numbers and they are called as x less than or equal to b, or a less than or equal to x less than or equal to b. This is the common notation for this. That is closed interval a b in നമ്മൾക്ക് എങ്ങനെ പറയാം? Boundaries are a and b, okay, and a and b are included, that is equal to, from a to b. So all x values can be considered including both a and b, including extremities. So this is a notation for closed interval. Then what about this one? Same notation, x less than or equal to b, but a and b are excluded. അത് വേണ്ട. ഇത് വേണ്ട. So this is a notation for open interval AB. Then similarly, semi-open or closed interval. Semi-open or closed interval. That is only one part is open or closed. This one. Here beginning bracket is for closed and ending bracket for open. This is what A is included, but B is excluded. Clear? Similarly, this one, A comma B, A is excluded, but B is included, equal to for B. Okay. So these are the types of intervals or interval subsets. Which are what? Which are the open, closed interval, open interval, and semi-open or closed intervals. So these can be considered or taken as the subsets of real number set when real number set capital R is taken. Let us introduce some operations on sets. First one, union of sets. Union. What is union? See, A is equal to set 1, 2, 3, 4. B is equal to set 3, 4, 5, 6. Then union of these two sets. Union means what? Combining up, joining. A and B, these are two sets. Then union of A and B. It is written as this one, union. U capital U symbol. A union B. It is written as A union B is equal to what is A? 1, 2, 3, 4 union. What is B? 3, 4, 5, 6. A union B. So by union we mean what? Joining of or combining up of these two sets. That is 1, 2, 3, 4. That is A. Then union 3, 4, 5, 6. 3, 4, 5, 6. So all elements of both A and B are included in A union B. 1, 2, 3, 4. Then 3, 4, 5, 6. But by the property of a set, elements of sets need not be repeated. So repetition must be avoided. So that is equal to what? 1, 2, 3, 4. Then 3 is repeated, that can be avoided. 4 also can avoided. Then 5, 6. So this is A union B. So number of elements in A is what? 4. Number of elements in B is what? 4. So in answer, total number of elements is what? 6. Why? Here two numbers are avoided. Which numbers? 3 and 4. 3 and 4 are common in both A and B. So by the condition of a set, elements of set need not be repeated. Okay. So A union B is equal to 1, 2, 3, 4, 5, 6. So that is all about a union. Intersection of two sets. Next one. Union. We discuss the union of two sets. Then intersection of sets. Here also I am taking two sets A and B. Then intersection of A and B. That is described as this symbol. Inverted U symbol. Intersection A and B. A intersection B. Intersection. That is equal to what? A means 1, 2, 3, 4. Intersection. B means 3, 4, 5, 6. Then by the word intersection, we mean that the common elements for both A and B. Only common elements. Here, which are the common elements in A and B? 1. Here 1, but here not 1. 2, not 2. 3, 3. Okay, 3 is common for both A and B. 3, 4, also 4, 4. So that is all about common part. Okay, 3 and 4. So this set 3 and 4, this is the intersection of two sets. Clear? By the word intersection, what we mean? The common part of both the given sets. By the word union, we mean that elements of both sets are written all together. That means comparing up of all elements of the given two sets. By the word intersection, we mean that what? We are taking only common elements from both A and B. Okay. Then third operation, difference. difference of set. Difference. Look here. Same set A and B. Then difference of A and B. A difference B. A minus symbol. കുറച്ചൊന്ന് സ്ലോപ്പ് ആക്കി കൊടുത്താൽ മതി. A difference B. A difference B means A difference B is the set of all elements of A which are not in B. എന്താണ് പറഞ്ഞത്? A difference B means the set of all elements of A but not in B. Here 1 is not in B, so 1 can be written. 2, set of all elements of A, 2 but not in B, 2 not in B, so 2 can be taken. Set of all elements of A, 3 in A but also in B, so 3 cannot be taken. 4, set of all elements of A, by the definition of difference, set of all elements of A which are not in B, 4 is in B, so 4 cannot be taken. So that is all about A difference B. Clear? So what is A difference B? A difference B is a set of all elements of A which are not in B. So we have obtained A difference B is equal to set 1, 2. Similarly, what will be B difference A? B difference A is equal to what? Set of all elements of B, 3. 3 is here, so 3 is not included. 4 also here, not taken. 5 not here, so 5 is taken. 6 not here, 6 is taken. So this is B difference A. So that is all about difference of sets. So union, intersection and difference. These are the 3 operations used in sets. So let us wind up this section here. So in this class we have learned infinite set, finite set, infinite set and power sets, property of elements in power set and its small formula, and then operations of sets, union, intersection and difference. These are simple operations. And we also learned interval sets, open interval, closed interval and semi-open or closed interval. Okay, so later part shall be studied in further classes. So now we are winding up here. Okay, thank you.